This is the Trig derivatives homework guide, and for the very first question, I need to find the derivative of sine 4x, and we know that the derivative of sine x is going to be cos x, so if we apply that to this particular problem, I get y prime equals to cos of 4x, and you can put a bracket there if you like, and then the chain rule states that you need to take the derivative of 4x, which is simply 4. So my final answer here for y prime would be 4 times cos of 4x. And once again, feel free if you want to put a bracket around the 4x or not. Alright, let's move on to the next question here. For this next question, I need to find the derivative of negative sine x squared. And the derivative of sine x is going to be cos x. So once again, if we apply that to this particular problem. Now, I have a negative sign here, so that's kind of like a negative 1. So a constants we just kind of leave in front. And then we just take the derivative of the function here. So derivative of sine is going to be cos of bracket x squared. And then the chain rule states that you need to take the derivative of x squared, which is going to be 2x. And if I multiply 2x with the negative 1 leading coefficient, my final answer would be negative 2x times cos of bracket x squared. Okay, so that's it for that particular question. Let's keep on moving along here. And for this next one here, I have y equals to 2 times cos of the square root of 2x minus 1. And the derivative of cos x is going to be negative sine x. If we apply that to this problem here, I have y prime equals. Now here's a constant, so the constant can just remain in front, and then we just take the derivative of the function here. So the derivative of cos is going to be a negative sine, so negative sine, and then another open bracket for the roots 2x minus 1. Close that bracket, and then I close the full bracket, and then I multiply by the derivative of the inside here, so the derivative of the square root of 2x minus 1. Okay, so if I just bring out another marker here, we know that 2x minus 1, I can raise that to the power 1/2, and if I take the derivative, then the 1/2 comes in front, and then everything in the bracket remains the same, so this is basically the chain rule here, and then we decrease the power by 1, so I have a negative 1/2, and then the chain rule states that I multiply by the derivative of the inside, and the derivative of 2x minus 1 is just 2. Okay, so this right here is the correct answer here, but let's see if we can simplify this if we can. So I know that there is a 2 here and a 1/2, so we can just cancel that off. So this 2 and that 2 will cancel off. And I will just take this part right here, and that will be on the numerator if I simplify this. So if I have a 2 times a negative sign, I get negative 2 sine the square root of 2x minus 1. And then this part here in red, all of this can go on the denominator as the square root of 2x minus 1. And then we know that y prime is on the left-hand side there. Okay, so that's it for that particular question there. And now we can keep on moving along. So being able to simplify is actually a very important skill to have in this homework video guide here. Alright, so the derivative of tan 3x. Okay, so the derivative of tan is going to be secant x all squared. So if I write out y prime, the derivative of tan is going to be secant squared bracket 3x. And then the chain rule states that you need to multiply by the inside there. So the derivative of 3x is going to be 3. And then if I move that 3 to the front, my final answer would be 3 times secant squared bracket 3x. Okay, so that's it for that one. Let's keep on moving along here. Once again, I need to take the derivative of tan of something, and the derivative of tan is going to be secant squared x. So you can also write this as just secant squared x there if you like. And if I just write out y prime now, so the derivative of tan here is going to be secant squared, and then everything in the brackets, ax squared plus b. And then the chain rule states that I need to multiply by the derivative of the inside here. So the derivative of the inside is going to be 2ax. And that's going to be my final answer for that particular question there. And I guess if we just continue and be consistent here, I guess we can write the 2ax, the coefficient in front. So 2ax. And then we have the secant squared bracket ax squared plus b. Okay, let's keep on going on. Number next one here. Okay, so now we're dealing with cosecant. So cosecant of anything, right? So the derivative of cosecant x is going to be negative cosecant x cot x. Okay, so let's apply that to this particular problem here. So I have y prime equals 2. Now here's my constant here, negative 1 over 5. So all the constants you just keep in front. And then you just take the derivative of the function here. So the derivative of cosecant 5x, if I use the derivative over here, is going to be negative cosecant and then bracket 5x times cot of bracket 5x. Okay, and then I'll close the bracket there. So that right there is just the derivative of cosecant, right? And now the chain rule states that we need to multiply by the derivative of the inside, right? So if I do that, I just get a 5, right? So we attach the 5 over here at the very end there. Okay, and all we can do from here is if I multiply this 5 by this negative sign and that negative sign and this 5, everything seems to cancel out. So this 5 and that 5 will cancel out, and this minus and a minus becomes positive. So the final answer here is just y prime equals to cosecant 5x times cot 5x. And that should be it. Okay, let's keep on going along. Okay, the next one here, I need to find the derivative of cosecant of something, and the derivative of cosecant, once again, is negative cosecant x cot x. So if I find the derivative here, y prime, so the derivative of cosecant there is negative cosecant root x times cot of root x. Okay, and then the chain rule states that I need to take the derivative of the inside right there, right? So I know that root x is the same thing as x to the power 1/2, and if I take the derivative of that, I get 1/2 x to the power of negative 1/2, and then I close the bracket there. Okay, so that right there is an okay final answer here. Let's just see if we can simplify this. So y prime equals 2. So this part right here in yellow, that part right there can be on the numerator. So negative cosecant root x times cot of root x. And then we're going to divide this by this expression right here, right? So one thing that you have to get used to is this x to the power negative 1/2. That's just really just the square root of x on the bottom. And this 2 right there, I guess I can put the 2 right there, and that should finish off that particular problem. Okay, let's keep on going. So for the next question, I need to find the derivative of y equals to tan of something. So the derivative of tan is going to be secant x to the power 2. And once again, you can write this as secant squared x. Okay, so if I find the derivative of this problem, I start off by writing y prime equals 2. Now the derivative of tan was secant squared and then bracket the square root of 1 minus x squared. And then I close that bracket. And then the chain rule states that we need to take the derivative of the inside there. Now the inside is just 1 minus x squared to the power 1/2, right? So if I take that derivative, the 1/2 comes in front. And then I have 1 minus x squared to the power of negative 1/2. And then just to finish off the chain rule, then we multiply by the derivative of the inside, and the derivative of the inside is going to be negative 2x. Okay, so that right there is the derivative. And what we're going to do now is we're going to just take this first part, and I guess we can multiply by that. And I'll take 2 steps to simplify this, but if I do that, I get bracket negative 2x times secant squared bracket the square root of 1 minus x squared, close the bracket. And then this part right here in green, that really goes on the denominator as the square root of 1 minus x squared. And then I guess we can say that this 2 here, which I'll circle in green again, that 2 can come in front like that. And then finally, if you want, I guess you can just cancel off the 2's there. So that 2 and that 2 will cancel off. So I'll erase that. And I guess on the numerator there, we just have a negative x now, right? So I'll put a bracket there and a negative x. And that is equal to y prime. So y prime equals to all of that in simplified form. Okay, let's keep on moving along here. For the next question here, I have y equals to sine of all that. So the derivative of sine is going to be cos x. So if I want to find the derivative of sine, I would start off by writing y prime equals to cos of square bracket and then another bracket x cubed minus 1 close bracket to the power of 4, and then I close the bracket there. And then the chain rule states that you need to multiply by the derivative of the inside there, right? So we start with the 4 now, so that 4 gets soccer kicked to the front, and then we have x cubed minus 1 to the power of 3, and then the chain rule states again that we need to multiply by the derivative of that inside, which is 3x squared. Okay, and that right there is totally fine. If you want to just continue simplifying this, all you can really do is take this 4 and the 3x squared. If you multiply the 4 and the 3x squared, you should get 12x squared. And then from there on, I guess you can just multiply by with everything else. So that will be cos of bracket x cubed minus 1 to the power of 4, close that bracket, and then you have all of this tagging along, which is just bracket x cubed minus 1 to the power of 3. Okay, so that's totally fine for that particular question as a final answer there, and let's move on to question number 17, I believe. Okay, so there's a lot going on in this particular problem. I guess we have a cos of a tan. Okay, so let's take this very slowly. We know that the derivative of cos x is going to be negative sine x, so let's start there. So this will be y prime equals to, the derivative of cos is going to be a negative sine, so negative, actually I'm just going to write this at the very bottom here. So we have y prime equals to negative sine, and then we open up the brackets and write everything else the same. So cos of bracket tan x squared, close that bracket, and then we close that bracket. Okay, and then we multiply by the derivative of the inside here. So if I want to find the derivative of this, we start off with cos again, right? So the derivative of cos is going to be a negative sine, and then I open up the brackets to get tan x squared, and then I close that bracket, and then I close the red bracket. So we're done with the derivative of this cos now. And then finally, we now take the derivative of tan x squared, right? So the derivative of tan is going to be secant squared, so secant squared x. So this will be a secant squared, and the inside is just x squared, right? And then we multiply using the chain rule one last time, and we get 2x there. Okay, and that right there should do it. There's not much we can do to simplify this. I guess we can kind of, the last thing we could possibly do is I can take this 2x over there and multiply with that negative leading coefficient, and that's about it. So if I rewrite my final answer, I get negative 2x times sine bracket cos bracket tan x squared, and well, actually there's another negative sign there, right? So if I multiply that, the negative sign there, I guess we get a positive now, right? So positive 2x sine cos of tan x squared, and then multiplied by a sine bracket tan x squared, close that bracket, times secant squared x squared. Okay, so a lot of brackets there. I think I missed one more bracket. There's a bracket here, so there should be another bracket there to close that off, and I think that should be it. Okay, great. So that's your final answer for that particular question there. Lots of brackets, and it's a chain rule, multiple chain rules for that particular problem there. Okay, let's keep on moving along now. We have a few more derivative problems here just to kind of practice the concept of taking derivatives of trig functions here. Next one I have y equals to sine cubed x. So I would actually recommend writing this out as y equals to the square bracket of sine x all to the power of 3. Alright, so the next part of this homework, the homework series, is that we want to deal with trig functions with these powers that are kind of placed on the inside. And that just really translates to the power being written on the outside with a bracket there. So if I take the derivative here, I start off by writing 3 using the power rule, and then bracket sine x, close that bracket to the power of 2, and then I multiply by the derivative of sine x, and the derivative of sine x is just cos x. And that's it for that particular question. I won't simplify this any further. The next one here, y equals to sine squared of 2x. So I will rewrite this as a bracket sine of 2x, close the bracket, all to the power of this 2, which is that 2 right there. Let's go ahead and find the derivative now. Y prime equals 2. Well, the 2 comes in front using the power rule, and then everything in the brackets remains the same. And then I multiply by the derivative of the inside, and the derivative of sine is going to be cos, so this will be cos of bracket 2x, and then the derivative of 2x is going to be 2 there. Okay, so that's it for that particular question there. I guess if you want to multiply the coefficients there, you can. 2 times 2 is going to be 4. Let's move on to the next question here, and for the next question here I have sine squared of 2x. So what I recommend for this particular problem here is I would rewrite this as y equals to the square brackets of sine 2x square bracket all to the power of 2. And if we go ahead and take the derivative now, I would write y prime, and using the power rule, this 2 now gets soccer kicked to the front. And then I have a square bracket of sine of 2x, close that bracket, and then I multiply by the derivative of the inside, and the derivative of sine x is cos x, so this will be cos of bracket 2x, and then the derivative of 2x is going to be 2. Okay, so that works out pretty well, and then from there all I have to do now is multiply the coefficients here to simplify this further. So y prime would equal to, I got 4 there, and then I guess I can write the sine of 2x times cos of 2x. Alright, so feel free if you want to put brackets around the expressions there. Not a big deal if you don't have the brackets. I would still understand what you have there. Okay, let's keep on going along here. I now have another power here, so now my power is another 2 there. So if I have to rewrite this, I have y equals 2. Now the coefficient 3 remains on the outside, and then you have the square brackets of cos of bracket x squared, close that bracket, and that gets raised to the power of 2. Alright, so now let's go ahead and take the derivative here. So y prime equals 2. Alright, so this 2 will get soccer kicked to the front, and 2 times 3 is going to be 6, so 6. And then square bracket cos of bracket x squared, close that bracket, and then I multiply by the derivative of the inside there, right? Now the derivative of cos is going to be negative sine, so let's put a bracket around that. So negative sine, bracket x squared, close that bracket, and then the derivative of x squared is going to be 2x. Okay, so that right there is the final answer. If you want to take this 6, this negative sign, and that 2x, if you want to multiply all that together, I guess you would get negative 12x. And then you just multiply by everything else, which is cos of x squared, and then sine of x squared. Okay, that's it for that particular question. Let's keep on going on. All right, so now I have some tan functions here, so let's rewrite the original problem as tan. And then this is really just x cubed inside that bracket plus, and then this 3 right here, what that really means is I have a square bracket and then tan x all to the power of 3. Alright, so this question is really just testing you whether you understand how to deal with those exponents there. Alright, so now we have a y prime, and the derivative of tan is going to be secant squared x, so I'll rewrite this as secant squared x. So this will be secant squared of bracket x cubed, and then we multiply by the derivative of the inside, so the derivative of x cubed is 3x squared. That's it there, and then now we have a plus sign here, and then this 3 gets soccer kicked to the front, so 3, and then square bracket tan x all to the power of 2, and the derivative of tan x is going to be secant squared x. And that should do it there. I won't simplify that any further. Okay, let's keep on going on. Okay, so now I have y equals to 2 times secant cubed the cube root of x. Okay, so y would equal to 2 times square bracket secant of the cube root of x, close that bracket, and then this 3 right here is really up there, right? Okay, so very similar to the previous question, we just take y prime equals 2, and then I take this 3 and soccer kick that to the front, so 3 times 2 is 6. So we're just using the power rule here, and then we write out secant bracket cube root of x, close that bracket, and then that 3 becomes a 2 using the power rule. And then I need to multiply by the derivative of the inside here. So the derivative of secant of anything is secant of that anything times tan of anything, right? So this will be secant cube root of x times tan cube root of x. So that right there is just the derivative of secant theta, right? And then the chain rule states that you need to take the derivative of that now. So we know that the cube root of x is really x to the power 1/3. So if I take that derivative, it's going to be 1/3 x to the power negative 2/3. Okay, so a very long answer there. And let's just work on simplifying all of this. One thing that I'll try to do this in one step here. So let's see if we can do this correctly here. So I see a 6 and a 1/3, right? So if I take 6 times 1/3, there's really a 2 on the denominator, right? So 6 times 1/3 is really just 1/2, right? So that becomes a, sorry, not 1/2. That would become a 2, right? So let me just erase this and that. I'll put a 2 in front of there. And then how do I deal with this part right there? That part just goes on the denominator as x to the power of 2/3. Okay. And that's it. I'll leave my final answer. I'll leave my final answer like that. Are there more ways to simplify this? There are, but I would just say that it would just take a little bit more time to kind of simplify this a bit more. If you take a look at this part right here, if you multiply that and that actually just becomes a single secant cube to the power of 1/3, but maybe I'll just leave that for now, and we'll accept that as a final answer there. Okay, let's keep on moving along here. So okay, let's take a look at the next question here. This one's a little bit of a challenge here because we need to rewrite this so that's in derivative, so that we can write it in a friendly derivative mode here. So let's see if I can rewrite this by starting with the inside here. I have 2x minus, and then I'll put a square bracket around the sine x, and then that will be raised to the power of 3. And then I have this square root sign, so I can put the square root sign as a power, as everything to the power of 1/2. So that's the first challenge with that problem. You have to write it so that it's in a situation where you can take the derivative a little bit easier there, and this is a lot easier to take the derivative now. So this will be y prime equals 2. Now using the power rule, that 1/2 gets soccer kicked to the front, and then I have everything on the inside, so 2x minus the square bracket of sine x all to the power of 3, and then I close that bracket, and then if I subtract 1 from here, I get negative 1/2. That completes the power rule. And the chain rule states that I need to multiply by the derivative of the inside there. So the derivative of the inside is going to be, starting with the 2x, will be 2 minus, and then there's a 3 here, so that 3 gets soccer kicked to the front. And then the brackets will be sine x, all to the power of 2. And then the derivative of sine x is going to be just positive cos x, right? So cos x. And then close that bracket off. Okay, so that looks pretty good. I would say that would be good for a final answer there. If you wanted to simplify this further, I mean, you could take this whole thing. Sorry, I can take this entire thing, and that, since that's being raised to the power of negative 1/2, that's kind of like everything that goes on the denominator as a square root, right? So this would be 2x minus the square bracket of sine x, all to the power of 3. And then this 2 right here would just tag along like that, and that 1 would be on the top. And then I guess we can just multiply by everything over here, which is 2 minus 3 square bracket sine x times cos x. And I wouldn't really simplify that any further there. That looks pretty good. And let's move on to question number 7 now. Okay, so question number 7, we have another long question here. I probably won't simplify this one just because it just takes a long time to simplify these expressions here. So if I rewrite this as sine of 2x all to the power of 3 plus square bracket here, I have cos of 2x all to the power of 3. Now it's in a derivative friendly mode here, so if I take the derivative now, I have y prime. So using the power rule here, the 3 gets soccer kicked to the front, and then I have the square bracket of sine of 2x, and then I can close that bracket off, and this gets raised to the power 2, and then I times by the derivative of the inside, and the derivative of sine is going to be cos, so cos of bracket 2x, and the derivative of 2x is going to be 2. Okay, and then I need to add that 2. Okay, so if I take care of that 3, the 3 comes in front, and I get cos of bracket 2x, close that bracket, all raised to the power 2, and then the chain rule states that I need to take the derivative of the inside there, so I need a bracket now because the derivative of cos x is negative sine, so this will be negative sine of bracket 2x, and then the derivative of 2x is going to be 2. Okay, so that's it for that particular question there. I'm just going to double check this really quickly here. I don't think I want to simplify this just to kind of save a little bit of time here. And that looks pretty good. Okay, so let's move on to the next few homework questions to kind of finish off this homework video guide here. Okay, so I have a few of these product rules now. So x times sine x. So let's quickly do this here. So y prime equals 2. The derivative of x is going to be 1 times sine x plus the first term, which is x, and the derivative of sine x is going to be cos x. And that's it. I won't simplify that any further here. Okay, so this one right here, I guess we can rewrite this as y equals to x squared times cos of bracket x to the power of negative 1, all in brackets there. And then if I rewrite like that, then the derivative is a little bit easier to compute. So y prime would be equal to the derivative of x squared is going to be 2x, and then multiply that by cos of, I guess here I can just rewrite this as 1 over x, and then plus x squared, and then the derivative of cos is going to be negative sine, so negative sine of bracket 1 over x, and then the derivative of 1 over x, well, we know x 1 over x is the same thing as x to the power of negative 1, and then that derivative is negative x to the power of negative 2. Okay, and I will leave my final answer like that. I'm just going to skip simplifying the last few questions here. I'm just going to take the derivative right on here for these questions. So this will be 3x times cosecant x to the power of 1/2. If I find the derivative of that, that'll be y prime equals to 3 times, okay, so this one I'll leave alone as cosecant x. The square root of that, and then plus the first term, which is going to be 3x, and then if I apply the power rule to this expression right there, I get 1/2 bracket cosecant x to the power of negative 1/2 times that, which is negative cosecant x cot x. Okay, so these questions here I won't simplify. I'll just kind of go through the derivative steps for these trig functions here. So all these are combo questions now. Using the quotient rule here, the derivative of sine x is going to be cos x, so bracket cos x times the bottom, which is 1 plus cos x, and then the quotient rule states that you need a minus sign, and then I can times by the top, which is sine x, and then I multiply by the derivative of the denominator, and the derivative of the denominator is going to be 0, and then the derivative of cos x is going to be negative sine x. Close that bracket, and then I just have the denominator all squared, which is 1 plus cos x all to the power of 2. Okay, and for sure you can simplify this a little bit further here, but maybe I'll just, actually maybe this one I will simplify this one here, so y prime. If we FOIL this out, I guess I get cos x plus cos squared x, and then if I multiply this with this, I get plus, and then sine times sine is sine squared x, and cos squared x plus sine squared x is going to be 1. So there's cos squared x plus 1. So if I erase the entire numerator here, I guess I just get cos x plus 1. And it turns out that we can keep on simplifying because this and that will cancel off, giving you just 1 over 1 plus cos x. Okay, so that's a very good one to practice for simplifying. Let's keep on going here. This one here, let's see if I can rewrite this as, okay, y would equal to sine of 4x times this bracket of cos x all to the power of 2. Okay, let's see if we can take the derivative now. So y prime equals 2. All right, the derivative of sine 4x, I can use this part right there. So that's going to be a cos of 4x times the derivative of 4x, which is 4, and then times cos x all to the power of 2. So essentially we're just using the product rule here, plus. So we just finished the derivative of sine of 4x times the second term, which is cos squared x. And then we times this, so then we continue adding now. So the first term, which is sine of 4x, and then we take the derivative of this guy, which is going to be 2 bracket cos x, close that bracket. And then the derivative of cos x is going to be negative sine x. Okay, almost done here. One last question here to go here, and I will do my very best to finish this as quickly as possible. For this question here, I guess I have another product rule here, right? So 3 times secant 2x times tan 2x, y prime. Okay, so constants stay in front, and then I need the derivative of sine 2x, so I can use this part right here. So the derivative of secant 2x is going to be secant x times tan x. Okay, so how do I apply that to this particular question here? I guess that will be secant of 2x times tan of 2x. And then I need to multiply it by the derivative of 2x, which is going to be just 2. And then I multiply it by the second term, which is tan of 2x, plus. Okay, and then what I can do from there is I can take the first term, which is, the first term is 3 secant 2x, so we're just taking this entire first term, and then we just multiply by the derivative of the second term, and the derivative of the second term, well, we know that the derivative of tan x is secant squared x, so this will be a secant squared of 2x, and then we multiply by the derivative of 2x, which is going to be 2 there. Okay. Alright, so hopefully that helps with some of the homework questions here. I feel like I was kind of running out of energy towards the last few questions there, and maybe I was mispronouncing like a sine x as secant squared x. I think at the start of this problem, I think I might have said that this was the sine, but it's actually secant. So, but I think all the steps here work out pretty well. I'm not going to simplify the questions on that particular section there, but the rest of the concepts look pretty good.